learn how to calculate it manually? Did you ever sit down and actually calculate it out? Did anybody do that? Maybe one or two of you did. Chrissy, you did. Oh, because you took it at Montana State. Good, good, good. But the rest of you, no. Just a conversational kind of idea. Can't remember. That's okay too. Hey, that's totally fine. Because I want to tie it back to this idea that you guys are kind of building together. Let's look at Ernie's. Ernie first. I'm going to start with his test scores. Okay? So his data, or his scores, I'm going to go ahead and call those X values, just because we've always called them X values. And I say always, we've been together for 5 days together. Totally. In those 5 days, we keep calling them X's. His test scores were, he had an 82, he had an 83, I think, he had an 80, 79, and 81, yeah, I believe. Okay. He had an average too, right? The average of these guys, you figured that out already? Yeah. It was 81 points. 81 points. All is well. All is well. Beautiful. I'm going to use Eric's idea fused with Kendra Linda's idea. I'm going to take each one of those data points and figure out the distance, the difference between that data point and the fixed average. So this should sound somewhat familiar because we just kind of did it with that graph. But watch what happens with this. This is why I think mathematically it's a little better. 82 minus 81 is 1. We knew that. We drew that one in before, right? 83 minus 81
2.
is 2. 80 minus 81. This is why it's a little more precise. Rather than just saying it's a distance of 1 away from average, you now also know which direction, which direction it went in. It's down 1 from average. Which means if you just had the list of deviations, you could tell where these data points lie with respect to average. 79 minus 81?
Down 2.
Down 2? Absolutely. 81 minus 81?
0.
Right at average. Right at average. We've taken our first step towards what's called normalizing data. Fantastically fun. Fantastically fun. All right. So let's just average those, yes? Gesundheit. Let's average. 0? 0?
Yeah.
So Ernie has no deviation. Because it averages to 0, right? Mm-hmm. Well, doesn't sound convinced. How can he have no deviation? How can he have no deviation? What's the only way Bernie could have no deviation? What is the only way?
Bernie.
Did I say Bernie?
Yeah.
I do that every year.
Nice.
What's the only way Ernie could have no deviation? Be brave. If all the scores were exactly the same. That's the only way to not have deviation, right? Want to see something kind of weird? Do the same thing for Bert. Let's do it together. Let's do it together. Okay, I'm going to do this kind of on the corner. But Bert's average is also 81, right? His low score is 61. That's 20 down from average, correct? Negative 20. I'm going to do this really quickly just to prove a point. His next low score was 68. I believe that's 13 points down from average. I believe, if I'm doing the math right in my head. His next score is at 82. That's 1 point above, positive 1. Fair? His second highest is 94. That is, I believe, 13 above. Is that right? And the next one is 100, which is 19 points above, right? Go ahead and average those values. What do you get?
0.
You get 0 again. As a matter of fact, it doesn't matter what data set you have. If you stop right there at this point, these will always sum to 0. I like this so much. And when I first saw this, my jaw was like, that's badass. And then I sat down and proved it. I'm like, oh, that's even badasser. I've got an extra credit opportunity for you guys in the extra resources page for the variability homework. If you can prove why it always is 0, I'll give you some extra credit points. It's open all term. It's up to you guys. You can totally ignore it if you want to.
Where is it at?
It's on the extra resources page for this. So when you go to that extra these resources link for the variability homework, it's nestled in there. It's one of the extra questions I made up at the bottom. Yeah, it basically, this is always true. That's always true. So in other words, if you stop there with any data set, it's always going to sum to 0. Which is really cool, and also amazingly frustrating, because it's useless for us to stop there, isn't it? Because that means that if we were to use that for variation, every single data set has the same variation. But we know that's not true, because we know that Bert is more deviant than Ernie. Numerically. Maybe not personally, but numerically, right? Not to quote sociologists here. Fair? Now, Eric.